So hi, I'm Sam. I'm the CEO and co-founder of DePoly. We're a Swiss-based company that is tackling the global plastic problem. And all of you in the room, the whole 7 of you right now, have probably all experienced plastic at some point today. You're probably wearing it if your shirt is made out of polyester, for example. And all this plastic has 2 things in common. The first thing is that it comes from the oil industry. So the majority of plastic that we interact on a day-to-day basis is taken from the ground, from the oil industry, refined, and then turned into the products that we know. It's a very linear economy. We produce a lot, we use a lot, and then the other thing plastic has in common is it's typically not recycled. And this is the kind of other side of the problem. Post-consumer household waste is extremely complex. It's blended, it's mixed with other plastics, there is food components on it, consumers put stuff in the plastic that shouldn't be there, and ultimately mechanical recyclers, which is the current industry right now that exists to recycle this, can't treat it, so it can't go back to those raw materials that would have been sourced originally by the oil industry. And so depending on where you live, there's sort of 2-ish options that are available. You can either landfill it. That's most of the North America's landfill. I'm from Canada, that's what we do. We ship it to a landfill, goes sometimes to the US. The US will then send it to somewhere like China. It potentially gets illegally dumped. Then you end up with plastic patches in the ocean and then microplastics in our food, which is one of the big issues that everybody's talking about right now. But if you're in the EU, if you're from Switzerland, which is where the company is based, we incinerate. And incineration is just, it's typically talked about as waste to energy recovery. But if you think about this in the long-term frame of everything, it's really just burning oil with extra steps. And this represents around 90% of the plastic that we produce on a yearly basis, which means that the majority of stuff that gets recycled is not actually making it back to the majority of the consumers and what we need. And there's a lot of initiatives out there. There's the Paris Accords, there's single-use plastic initiatives to ban things like straws, but plastic is not disappearing. It's a $580 billion industry that's growing, and by 2050, we're expecting that 20% of the oil produced is going to be consumed just for plastic production. And this all has a CO2 footprint tied to it. So while we are trying to offset global emissions through our day-to-day activities, through other initiatives, we're going to take basically one step back and offset that by 50% just from plastic production. So this is just plastic. This isn't automotives, this isn't flying, this isn't anything like this. This is just plastic production by 2050, which is really scary because I don't know if anybody here has realized what the weather's like. Spring didn't really exist for most places. Like there's massive changes happening. And it's something that needs to be tackled now and not in 10 years. And so this is where and how DePoly was really kind of made. So what we wanted to do is we wanted to create a simple, sustainable solution that could tackle post-consumer household waste that would be otherwise incinerated or landfilled. So we didn't want to go after the easy stuff, we wanted to go after all the hard stuff. And we wanted to convert that back into the raw material. And we did. We made a process. It's a very straightforward process. So we get that post-consumer household waste that we had talked about earlier in the presentation. We shred it. So we don't pre-wash, we don't pre-sort, we don't pre-separate or pre-melt or anything like that. We shred it so that it flows in a reactor and it doesn't clog or clump. And then we put that into the chemical recycling system that we've developed. This doesn't require heat, it doesn't require pressure, and all the chemicals and solvents that we use, you probably interacted with while you've been here in London. It's all consumer-based stuff, it's all commodities. We're not working with rare earth metals or anything heavily toxic. So we use that for our system, and then at the very end of the day, we get the PTA, so the purified terephthalic acid, and the MEG, monoethylene glycol, out at the very end. This, we are hoping, will be drop-in with the existing chemical industry. We're not looking for chemical industry to change the infrastructure that they already have. We want to be able to incorporate directly into the process that's making plastic already. And you can take that, turn it back into PET, put it back into the stream, have that mixed waste, and go through the entire thing. So you have this closed loop of infinite recycling for PET plastics. If you remember the post-consumer household waste mix there, has a lot of blends. So if you have cotton polyester, polyamides, polypropylenes, polystyrenes, etc., because the reaction is very simple and it's very non-aggressive, we can actually recover those afterwards and give those back to mechanical recyclers that exist to transform those back into 100% recycled items. So in the case of cotton polyester, for example, we've recovered the cotton, given that back to somebody, and they've basically said that they could use this to then make a 100% recycled cotton item. In terms of what we tested, we've really worked with everything. We've gone from high-end, low-end luxury brands. We've done the stuff mechanical recyclers can do, which is really easy, and then the stuff that they reject, which is the more fun stuff. We've done pre-consumer household waste, post-consumer household waste, post-industrial waste, heavily contaminated stuff, and even ocean-based plastics that have been recovered through cleanup projects. And in all cases, there's not anything in this kind of garbage stream that would stop or hinder the reaction. The reaction proceeds and the PTA and MEG come out, meet their virgin oil counterparts. So we can do this reaction regardless of how dirty it is and turn it back into PET. The PET right now we're taking and we're using for proof of concept projects. So we're working with customers to turn it into jars, bottles, clothing, outdoor sporting good and equipment. We'll start having some press releases probably within the next year. So just keep an eye out for that. And then we can demonstrate more on what our technology can achieve and what it can be turned back into. Now, when you're going up against the oil industry, you typically have to prove that you're better than it because otherwise it doesn't make sense. So we did a third-party life cycle analysis, and this is our Gen 1 plant. This was a 2-ton batch process that we developed back in 2021. And at that point, we already had a 65% lower CO2 footprint than the current existing virgin production industries through oil. Since then, we've actually developed a Gen 2, and then I guess a Gen 2.5, and we're actually expecting this LCA value to drop dramatically because it's now a continuous system, it's not batch. We've incorporated solvent recovery and some other options in there to minimize our CO2 footprint. And if you look at it from just a waste-based approach, we actually have a negative CO2 footprint, and this is due to recycling credits that are applied. But the majority of the CO2 from our process doesn't actually come from the process. It's to develop the chemicals that we use. So for example, one chemical is ethanol. You can do that as a technical grade, or you can do it as bio-based. Bio-based is a little bit more expensive in Switzerland to get, so we've been working with technical-based. So moving into the future, we can also choose sustainable options to offset that as well. And all this, in the terms of developing the technology, scaling the technology, growing the technology, plays a massive role in the amount of CapEx that's required. Because the more complicated a system is on a lab scale, the more expensive it's going to be when you get up into that industrial area. And so compared to our competitors, we have a significant CapEx reduction because of this, and we're hoping to pass those savings along then to the PTA and MEG or PET that we put back into the market, because our goal is to have the best unit economic prices as possible, ideally market prices, so that companies don't have to choose between sustainability and profits. They can choose sustainability, they can have their cake and eat it too at the end of the day. To grow this, to get into the kind of commercial scale, we've been working on this since 2020, so we're now at the pilot phase. Right now we're doing hundreds of kilograms with customers for proof of concepts. This is to introduce them to the concept of chemical recycling, what it can do for their product. This leads them into the showcase plant, which will be operational at this Q2 next year, so by this time we should be fully online. These will be lighthouse projects. This will be to introduce product directly into their line where customers can actually hold it. So this could be, for example, limited edition t-shirts, shoes, bottles, makeup containers, etc. But they'll actually be able to demonstrate to their customers that they have it in hand, that they've done this. And then we move into the first of a kind, so the FOAC, and the next of a kind NOAH plant. These will be full commercial scale plants, fully integrated into the supply chain, integrated into the industry. We're looking around 50,000 tons per year for each of these. And the end of the day, the goal is to get to licensing. It keeps you CapEx light, even though the first kind of 3 stages here are still quite CapEx heavy. But moving towards licensing keeps you much more CapEx light. And then for the funding process for this, we'll go with our standard equity kind of debt subsidies that we can get until the technology is fully de-risked. Then we'll start looking at debt, other financing vehicles that are out there. And then into licensing, you have more of the JDA, JDV kind of combination between the two and less on the equity side. Our team right now is 25 people. We have a wide background from everybody. We have a small UN that's basically formed, I think, with the amount of people from different places that are all working together to bring us to this commercial scale and to then solve the plastic problem. But the 6 people that are managing and operating the company are myself, Chris, and Bardia. We started the company back in 2020. Very academic, very technical experience. So to round out the team, we have David, Eric, and Miguel on the financial, commercial, and operations side. So everybody here has background, for example, in startups, in the commercial side, in operations, how to bring plants into like the next scale. And so we have quite, I think, a well-structured team to achieve this. Yeah, very kind of quick to the point. Happy to answer any questions, and thank you guys for listening.